Okay. Go ahead, Aubrey, again. What does the 8 stand for? The atomic number. And we can just use the number sign for a number. And atomic number equals the number of what? You may need to use your Adams notes for this, Carter. Number of protons. Number of protons. Okay. What does that O stand for? Hutley?
Atomic label.
Okay, it is our label, the element label or symbol. Symbol. It is the element symbol. Fisher gets one. And then one's Kenley's. No, I'll take it. Thank you. Okay. What's the word oxygen telling me, Elise?
What element it is? Like the element name?
The name. Good job. The element name. Element name. What about that 15.999, Addie?
Atomic mass.
Good job. Atomic mass. Now we're going to talk about the math. Let's go down to where it says atomic mass equals the number of blank plus blank. Atomic mass equals the number of blank plus blank. Aiden.
The atomic mass equals the number of protons plus neutrons.
Protons plus neutrons. Okay, if we were working with the element oxygen, what would we do to that 15.99999, Gabe? Yeah, we would round it. We don't turn it. We're not witches. We can't magically make them change. Okay, but we can round it to 16. Now, which particle, which piece of an atom have I not mentioned yet? Addie? Electrons. Which blank do you think it goes in? Yeah, it's the only one left, but who can tell me why it goes there? We don't usually word it like that. We know that the atomic number tells us the number of protons. Why does this say or electrons, Carter? Yeah, because protons and electrons are the same. Number of protons, number of electrons are the same. Okay, so we are going to use that information to fill in the elements below. We're going to skip oxygen because it gives us a lot of it there. Let's go down. Let's go to zinc. Okay, and do we need our periodic table for this? No, because it gives me almost all of the element label. Okay, from the periodic table. Now, we may have to go because what's missing from this one? Braylon? The label, the symbol. Okay, do we have all 120 symbols memorized? No, so that we will need the periodic table because we are not that good yet. You probably won't be that good for a few years. That's okay. Elia, what is the symbol for zinc? ZN. Good job. And the first letter is always capitalized. So fill in ZN for zinc. Now it's really just being able to come up with all those other important numbers. Augie, what is the atomic number for zinc? 30. We just have to know where to look. Atomic mass, the way we want it to be. Hutley? 65. Because remember, this is our target number. So we look at the 3 to help us decide, is that 5 going to stay a 5 or is it going to bump up? Hutley's saying it's going to stay. Do you guys agree?
Yes.
Number of protons, Bryson? So let's go back to the top. Read the top. Read the notes that we just wrote at the top. Where we wrote protons. What do we know about the protons? Okay, why is it 30?
Because the proton and electron, the protons or electrons are the same thing, the same mass.
Okay, but we don't have electrons yet. So how else do you know that it's 30? Lexi? We don't add. Addie, B?
The atomic number is 30.
Yes, our notes just said the atomic number is equal to the number of protons or electrons, which means our atomic number tells us our number of protons. It also tells us our number of electrons because protons equal electrons. Number of protons equals number of electrons. Now, neutrons, if we're finding neutrons or if we're finding atomic mass, it has to give us one or the other. We are always going to have to do some math. Okay, math is involved in either neutrons or mass, depending on which one we're looking for. So, what do we know about neutrons? Hutley?
Protons plus neutrons, but equals the number of atomic mass.
Okay, so I know protons, which is 30. I'm just going to draw an arrow where that number is coming from. Protons plus the number I don't know, my neutrons, has to equal what? 65. If you can't do that mentally, what fact family problem could you do, Braylon?
Do 30 plus 30 and then add 5.
Okay, that's like kind of processing it using like logic and reasoning, but that's not a fact family. You're right, that way would get us there. Lainey?
You could do 5.
No. I'm going to stop you. Aubrey?
65 minus 30.
65 minus 30. Remember fact families? 5 plus 6 equals 11. 6 plus 5 equals 11. 11 minus 6 equals 5. 11 minus 5 equals 6. Those are our fact families. It's been a while. Okay? But if you're ever missing one of the add-ins, you can always take the 65 minus 30, or again, use mental math like Braylon kind of processed it out to figure out that 30 plus 35 equals 65. So that would be our number of neutrons. Okay, let's look at Li. Do I expect you to know what Li stands for? No, but I expect you to be able to find it. Clara, find what Li stands for. How can you find that? Okay, how do you know where to look? You use the atomic number of 3. So what do we call that, Clara? Lithium. Lithium. Good job. Atomic number, Addie J.
3.
How do you know?
Because the atomic number is the number right above the...
Yeah, it's at the top of our label. It's always at the top. Sometimes it's in the top left corner. Emma, if I know the atomic number, what else do I know?
Oh, the
Protons
protons.
and electrons. So we know protons and we know electrons. Which other one am I given, Gabe?
The atomic mass.
Okay, what is the mass of this one the way I want it to be?
We want to round it up to 7.
to the nearest whole number, which you are correct, is 7. How do I find my neutrons, Lainey?
3 plus, I don't know, equals 7.
Okay, good job. And I'm going to also, from this atomic mass, draw an arrow to show where those numbers are coming from. So where did she get this 3? Lexi? Number of protons, because it's the number of protons plus the number of neutrons equals the atomic mass. So what number plus 3 equals 7, Jackson?
4.
4, good job. So let's fill in our missing box. So our number of neutrons is 4. I'm going to give you a minute. I want you to try this one and this one. Try those two. I'm going to leave my work up there for a second. Again, if it's not mental math, you may need to go to this side and do a subtraction problem, but everybody should have a math problem underneath the bottom. Braxton, help me get going. What is the atomic number for this one?
80.
We're looking right here. Where do we find the atomic number? Emily, can you help him out? 14. It's right there. It's that number right at the top, Braxton. 14. Atomic mass. Aiden? 28, because we round it to the nearest whole number, and that's our number down there at the bottom. Number of protons, Lexi? How do you know? Because it doesn't tell me that anywhere. Yeah, because your protons and your electrons are the same as our atomic numbers. I'm going to go ahead and fill that one in too. Now remember, neutrons or atomic mass, you will always need a number sentence. Hutley, help me with my number sentence.
14 plus box plus 28.
Okay, 14 plus box equals 28. Let's say that's not mental math for us. What math problem could I use to find that answer, Braylon?
28 minus 14.
Yeah, so if you are struggling to find that, write in our fact family that we use to find it. So 8 minus 4 is 4. 2 minus 1 is 1. So in the element silicon, there are 14 electrons, 14 neutrons, and 14 protons. What am I missing? Elise? The symbol. What is the symbol for silicone? Si. Good job. Okay, next one. Bromine. Gabe, what is my symbol? Br. Atomic number. Bryson? 35. Mass. Fisher? 80. How'd you come up with that?
Because 79, if you round it to the nearest, and it's 80.
Okay, good job. Protons, Lainey.
35.
How do you know?
Because that's your atomic number.
Okay, what else is 35 if that one's 35?
Electron.
Electrons. What is my math problem? Ava?
35 plus box equals 80.
35 plus a number I don't know equals 80. What fact family problem could I do to figure this out? Emma?
80 minus 35.
Good job. 80 minus 35. We would have to regroup 10 minus 5 is 5. 7 minus 3 is 4. So we found that there are 45 neutrons. Lexi, do you have a question? Okay, set this paper aside, but don't get rid of it. Set it aside, but don't put it away. In your notebook, I want you to go ahead and flip the page to page 11. What do we already have started on page 11, Elise? What's the title of our paper? Atomic Models. What we're doing on the Adams Family worksheet goes directly with drawing the atomic model. Mason, pick a number between 1 and 15.
13.
13. Hutley, flip back one page in your notebook. Tell me, what is element number 13? It's a hard one to say. Aluminum, is that what you said? 13. Okay, aluminum. So we're going to do another example. We labeled the first one example 1, didn't we? Okay, so let's write example 2, aluminum. Why should that word sound familiar? What is aluminum? Fisher?
It's like the big soda cans.
Yeah, it's all our soda cans are made out of. Okay, when we are drawing an atomic model, what is it important for me to know? What do I need to know to be able to draw an atomic model? Hutley?
The protons, neutrons, and electrons.
Yes, I need to know how many protons, electrons, and neutrons there are. Pen. So for aluminum, I'm giving you the name of it. Mason gave us the number, but if I just give you the name, what would you have to do? Go find it. Mason, do you remember the number you picked?
13.
13. So let's write out next to it that its atomic number equals 13. Is that important?
Yes.
Yes, very important. Why is it important, Addie B? Yeah, that tells me how many protons and electrons I have. So I'm almost ready to start drawing this. How do I find the number of neutrons, Lainey?
You do your atomic number plus square equals.
So protons, which is 13, plus, you said square, just because the number I don't know, the number of neutrons.
Equals 13.
It doesn't equal 13. That's my atomic mass. What are we going to have to pull from our periodic table, Carter? The atomic mass. What is our atomic mass? 27. Does it say 27, Carter, or did you have to do something to that number? You had to round it to the nearest whole number. So to find my neutrons, I take my number of protons plus the number of neutrons that I don't know, and it has to equal my atomic mass that we got from our periodic table. What is my fact family problem, Augie, that I could do to figure this out?
27 minus 13 equals
14, good job. Fill it in there. Now we have to draw it. Where do I start drawing my models? MK? Okay. She said the small circle, and then she said it right. The nucleus, the center. We start in the center of the atom, the nucleus. What particles are in the nucleus, Bryson? The protons and neutrons. Do I have to get fancy and draw a bunch of protons and neutrons? No, we're doing it the lazy way. We are going to say that there are 13 protons. How many neutrons? 14 neutrons. Where do I put my electrons, Hutley? On the outer shell. What is that? I just make rings, okay? I'm going to make one to start. How many electrons can go on that first ring, Ava?
2.
Just 2. So let's put 2 on there. Does it really matter where we put them? No. Nope, not right now. I just like to spread them out. Okay, we'll put 2 on there. Now we're going to draw another ring that just gets a little bit bigger. Does anybody remember how many electrons can go on all of the other rings? Elise? 8. Okay, so let's go ahead and draw. How many more do we need still?
11.
We need 11 more. So if I put 8 on this ring, will I still need another ring? Okay, so let's go ahead and put 8. When I'm putting 8s, I put them in groups of 2 just because they're easier to count. 2, 4, 6, 8. Okay, how many do I have right now?
10.
I have 10. How many do I need, Fisher? I need 3 more. You're right. So I have to draw a whole nother ring. And again, I just space them out. And add your last 3 electrons out there on the outside ring. Now, we're going to draw one more together, and this depends on how big you draw. I'm going to hold up Elia's notebook. Okay, Elia draws pretty small, so she has plenty of room to do another model. Jace, hold yours up. Okay, Jace wrote bigger, which is fine. I want you to just stay neat, so it doesn't matter how big you are. So, Elia has plenty of room on her paper that she's on. If you took up the whole page with those 2, just put your other one over here. That's kind of why we left that page blank, to where we had extra space if we needed it. Okay? So Jace, you'll just do yours over there on the left side. Okay, Elia, pick a number between 5 and 20. 10. We are going to draw the element that has atomic number of 10. So example 3. Who can tell me what element we are talking about? Clara? Neon. Ooh, we can't do neon. There's a reason. Sorry, pick a new number. Can't tell you yet. What? 15. Look at 15. Clara, tell me what 15 is. I'll tell you if we can do that one. Phosphorus. We can do phosphorus. That one's an okay one. Okay, so let's write example 3 is phosphorus. What number is it? 15? Okay. Wyatt, what else do I have to write down here? What else? What am I going to need to be able to draw the picture? Our protons and neutrons, and what else? Electrons. We need protons, electrons, and neutrons. Mason, how many protons does phosphorus have?
15.
How do you know?
Because there's a number of that's the atomic number.
The atomic number tells us our number of protons. What else does that atomic number tell us, Emma?
Electron.
Our number of electrons. Bryson, how do I find neutrons? Because neutrons is one I'll always either have to find or I'll have to find the atomic mass. Okay, I have to look at the atomic mass on our periodic table, and you're telling me it's 31? Okay, so what has to equal 31, Bryson?
15.
Our protons, which is 15. Good job.
15 plus 5 equals 31.
Yeah, 15 protons plus our number of neutrons has to equal 31. Gabe, how many neutrons do we have? 16. What math could you have done to figure that out?
I did 6 plus 5 and I did that equals 11. So then I just did 15 plus 6 I did, and I knew that equals 11, so I just added 2 ones.
Okay, so Gabe used a whole lot of like logical reasoning, breaking numbers apart. What's the subtraction problem you could have done?
31 minus 15.
Yes, that would have got us there. Does Gabe's way work?
Yeah.
Yeah, if he got 16, Gabe's way works. Okay? Now to draw it. Jace, where do I start when I'm drawing it? Where did we start on the last one? Or what shape do I start to draw? A circle. Who remembers what we call that very first circle that is in the center, Aliyah? The nucleus. Aiden, what belongs in my nucleus? Protons and my neutrons. And I don't have to draw all the circles. I can just show that there are 15 protons in there and there are 16 neutrons. Now I have to draw my electrons. Jackson, how do I get going on those?
You draw a ring around the nucleus.
Okay, I draw a ring, which we call the electron shell. How many electrons can go on that one?
2.
2, good job. Okay, who can take over for Jackson? Carter, go ahead. Okay, I draw another ring. And I can put how many on there? 8. Do I need 8 more? Yes. Yep. So let's draw 8. And again, it's easier to count 8 if you kind of group them in twos. Okay. Do I need more electrons?
Yes.
Okay, let's go ahead and draw another ring. Elise, how many electrons do I have so far? 10. So how many do I need to put on that last ring?
6.
I have 10. How many do I need altogether?
16.
What's on those outer rings?
31.
Lainey?
5.
5. Why 5?
Because you already have 10 and then 5 more.
It's electrons. It's electrons. So we need 15 total. So yep, I need 5 more. 1, 2, 3, 4, 5. Okay, now I'm going to tell you what you're doing for homework. You're doing kind of a mixture of the two things we did today. So flip your Addams Family worksheet over to the back side. You are going to do the top 3 on the back side. Okay, so make yourself a note that you're just doing the top 3. Are you doing all 9 of them? No. Which 3 are you doing? Just the top 3. So Emily drew herself a line. Wyatt drew himself a line to show him you're only doing the top 3. Okay, and then I have a separate piece of paper that I'm going to give you, okay, that says atomic models. And they only give us one box to draw 3 models. That's not big enough for us. So we're going to draw 1 of them on front, 2 of them on back. The reason we skip neon is because neon's one you got to do for homework. But I will tell you this once I give you the paper and we'll get it all set up. Okay? Okay, on your atomic model worksheet. Okay, I'm going to read you the directions. It says, for this activity, you will draw atomic models of these 3 atoms: fluorine, neon, and sodium. Okay? Down in the box at the bottom, they wanted us to draw all 3. We're not going to squeeze them all in there. I want you to write in that bottom box fluorine, which is F-L-U-O-R-I-N-E. Under that, I'm going to help you out. I want you to write P-E-N. Will you need to know numbers next to those 3 letters to be able to draw the model?
Yes.
Yes. Okay? Will you need your periodic table?
Yes.
Yes, so you will need your notebook with you when you're completing this. Flip that paper to the back. Draw a line kind of halfway through it. You're splitting the paper in two. Okay, you can see mine right here. Okay, so this is on the front. On the back, you just split the paper in two. On the top half, label it neon, and then write P-E-N. What do you think we're going to put on the bottom half? Sodium. P-E-N. I will tell you, because there's lots of elements on the periodic table, if they're having us draw them, do you think they're going to be close to the high numbers or the low numbers?
The low.
The low, because the higher the number, the more protons, electrons, and neutrons it's going to have, and it's harder to draw. Okay? So when you're looking for them, don't look. If you struggle finding them on the periodic table, come see me and I will help you find them, because that's not supposed to be the hard part. Okay? Any questions on what you're doing? So you have 3 Addams family problems, 3 atomic models. Okay? You guys can go ahead and get started on it.